Okay, we're looking at angles with planes in this video. So first thing is angle between two planes. So first we need their normal vectors. So I'm going to go normal 1 is 1, 2, 3. I'm very creative when I come up with questions. Normal 2 is 2. The y bit is 0 and the z bit is -1. Just be careful of that. Angle between two planes has this formula. Inverse cos, you dot the normals and you mod the normals. So all right, so if we dot the normals, let's see what we get. So you got 2 plus nothing, take 3. And if you mod the normals, you're going to get square root of 14 and square root of 5. Now, there's a modulus sign on the dot product as well. So that should be mod of 2 take 3. Just to show every step, that is mod of -1 on the top. Now, mod of -1 means that you turn it into +1. So that's cos inverse of that stuff, a 1 over root 14 root 5, and that's something we can just work out on a calculator. $83.1. Okay, so that's the angle between the two planes. And you can sort of imagine this as like, there's one plane, and there's a second plane. If they happen to intersect in a line, for example, planes can intersect in lots of different ways. But then you're sort of looking at that angle there between the two planes. All right, next we got a line and a plane. So for line and a plane, you need the normal of the plane and then the direction vector of the line. I've purposely put this line in Cartesian form just because then it can help us get the direction rearrangement and practice that skill. So we set all this equal to lambda, so x plus 1 equals lambda. So x is -1 plus lambda. We've got y take 1 over 2 equals lambda. So y take 1 is 2 lambda. So y is 1 plus 2 lambda. And we've got z over 3 equals lambda. So z equals 3 lambda. So the equation of the line sort of looks like this. -1 plus lambda. Y is 1 plus 2 lambda. And z is 3 lambda. And really importantly, the direction vector is 1, 2, 3. Again, I'm not very creative here. Cool. The plane here, we've got the normal vector, -1, 2, and 1. And all we need to do is apply that formula. So inverse sine n dotted with d over mod n mod d. And just check if there's a mod around the top. Yes, there is. I always forget these formulas. Cool. All right, so we've got to do n dot d. So I might actually just do that off to the side here. So it's -1 times 1, 2 times 2, and 1 times 3, which is 6. So you get inverse sine of 6 over mod of 6. Root of 6, and then the direction vector there is root of 14. Okay, so there we go. 6 on the top, root 6 times root 14 on the bottom, 40.9. Now, if you want the graphical interpretation of this, you got a plane, you got a line, and then this sort of makes some angle to the plane. Cool. All right.